Hello. I was really hoping my first video would be a nice half-hour documentary on how DC motors work, but it's going to be a tutorial on hexagons because what's out there right now is not the most fantastic. So, this is going to be creating a hexagon field, probably as the thumbnail shows, in Solidworks. Let's get started with a new sketch. I'm going to use the front plane. It doesn't really matter which one you take. Use the polygon tool to create a hexagon. Note, I am making the hexagon angled at 90 degrees, as SolidWorks calls it. You want to have a vertical edge here. Don't use horizontal. All the math in this video is for this orientation. If you're crazy, you can adapt it, but if you're here, probably not going to happen anytime soon. Give it a dimension. I'm using 10 mil, and that should fully dimension the hexagon. Notice how all the corners are black and you can't drag. That is important for it to look nice. You don't have to fully dimension things in SolidWorks. Just things tend to work better when you do. I'm going to do the same thing again. This one is not going to be fully dimensioned. However, it will have the same properties. I suggest, if you want to make the model more dynamic, you can select these two edges and make them equal. And then if you resize this one, the second hexagon will follow. Again, not necessary, just a kind of best practice. We're going to create a new center line. SolidWorks will highlight this point in yellow, make it orange when you have your cursor over it. So use the center point of the lines closest to each other. That's not something that will translate well onto text, but you can see what I'm doing. And then select that center line and make it perpendicular to the second hexagon. That should nearly fully dimension this hexagon. It will only be able to move along this line, and then we're going to use the dimension tool to give this thing the dimension of the material thickness. I'm going to use 2.5. So again, what's inside the hexagon will be cut out. What's outside the hexagon will become material in your part. And that should be now fully dimensioned. Now we're going to do some measuring. We're going to use the evaluate tool and measure from center point to center point. Note the dx and dy values. My dx is 9.91, my dy is 1.17. I can show you how to do the trig at the end of the video. I wouldn't suggest it. I personally hate trig. It's probably why I'm making YouTube videos instead of money. Next, we're going to go to sketch and create a linear sketch pattern. Make sure to select everything that you've created so far. That includes the dimension and this small construction line. And then click linear sketch pattern. Our offset is going to be the dx value, that's 9.91, multiplied by 2, or the trig, if you're going to use that. And the count is going to be the number of hexagons you need, so we're going to put 6 in there. Check dimension X spacing. Again, that will make the model easier to work with in the future. And then click OK. Clean that up a bit. Awesome. And then we're going to repeat the same thing for the horizontal linear sketch pattern, selecting all of the hexagons. This time we're going to select the x-axis count to 1 and the y-axis count to half the number of hexagons we need. So I'm going to select 3. dy times 2, so that's 17.17 in our case, times 2 will be our dimension 2 or y-axis offset. And once again, checking dimension y spacing. You might have gotten this in the previous step, depending on how large of a field you're making. SolidWorks likes to complain about the number of relation. I don't know, I have a beefy computer, I don't care. So that will give you a nice hexagon field to work with. Alright, in this next part, I'm going to show you how to make this a crude 3D shape. Chances are you've drawn this against an existing face that you want to cut holes into. If that's the case, you can just extrude the cut right away. It'll automatically select the internal area of the hexagons and kind of cut those holes out. If you do want to make this its own 3D shape using the space between the hexagons, what you will want to do is go to Sketch and draw a box around it. Make sure it doesn't catch any of these like auto snap to. It's just in free space. Since we fully dimensioned this field, we can very easily connect the box to the edges of the hexagon and it won't completely screw up your drawing. Ask me how I know. you can spend a good amount of time cleaning this up if you want to do cutting the corners around, and the trim tool is really useful if you want to play with that. You can cut out corners. I've tried to do it in a couple of takes, and every time it ends up just being grunt work, which you don't really need to watch. So we're not going to get into that. I will show you one. We'll just cut out this corner just as an example so you can kind of extrapolate from it. We're going to draw a line like this, make it parallel the hexagon here, and give it an offset of 2.5 millimeters, which is our material thickness. And then the trim tool, you can just slice through a corner like that. Basically what you're looking for is to keep, oh, that's going to drive me nuts, the area that you want material to be light gray, and Solidworks will figure it out. If you have incomplete edges, like for example, if we had not fully finished that trim and there was this thing just lying there, Solidworks will get pissed. Also avoid blue. Everything should be fully dimensioned. Once you have a satisfying outline to your hexagon field, ooh, look at that lag. It's not kidding about performance. Maybe not so beefy after all. Go to Features, Extrude Boss Base. Since you have the sketch selected, it will automatically select the area. And then just determine your height. Click OK. And now you have a 3D cutout, or yeah, hexagon field. There you go. Easy as that. I just put my mic away and remembered I forgot to do the trig. It's not actually that difficult. We just break a portion of the hexagon down into a right triangle. We know the internal angle here is 30 degrees because point to point is 60. It's half of that. We know the length of this, the opposite face, because it's half of this dimensioned line here. So this will be 5. And then we just use tan of theta equals opposite over adjacent. We know obviously theta 30. Opposite's going to be 5, and adjacent is the one that we're trying to find out. Rearrange that formula to adjacent equals opposite over tan of theta. Calculator. Just going to be 5, the opposite, over tan of 30, and we got the full number here. Simple enough. Horizontal from here to here is just equidistant to the vertical line. So that's going to be 10 mil. And then when you're doing your offsets, you just add the spacing between the hexagons to that figure as well. It's honestly easier just to use the evaluation tool unless you need pinpoint precision.